if you're into building large language model apps or essentially building leveraging generative AI, things like ChatGPT or Google Gemini, and you're trying to build something like a RAG architecture or basically build a chatbot for an environment, or you're looking at more advanced use cases, you would have stumbled upon something called as agents. Now, AI agents are getting extremely popular and everybody's talking about them, and there's a bunch of frameworks out there. So in this video, I want to double click on what AI agents are and basically talk it from a perspective of, what can single agents do, what are multiple agents, and take a deeper dive into the progress and some of the challenges and details around the multi-agent scenario. This is fairly advanced. I'm discussing this of a survey paper which just came out a few weeks back. So stay tuned for the entirety of the video. You will learn. All right. So this is the paper. It's titled Large Language Model Based Multi-Agents, a survey of progress and challenges. For if you're not familiar with what a survey paper is, it essentially looks at a bunch of research done in that space till that point in time and kind of just, captures and provides you an essence of all of the different research papers. So if you want to learn about something new or something trendy, survey papers are a great place to start. This is from a good set of authors. You can find a bunch of survey papers, but usually try to limit to yourself from very research oriented colleges and you'll get good stuff. This is from 19th April, so about 2 months old and fairly recent in that world. So what do we have? I've highlighted a bunch of stuff so that you don't have to read the entire paper. So large language models have achieved remarkable success, and it has been around wide variety of tasks. You can have something like a summarization agent, you can have a chatbot agent, you can do search and retrieval, you can augment information and a bunch of stuff. And the number of domains it can be applied to is humongous. You could be automating your call centers, you could be responding to your customers' query, you could be responding to your employees' queries, you could be looking at something like a productivity bots which can assist you in project planning, task management, code generation. They're all around us. Literally every tool that you see nowadays has some flavor of AI. In fact, few weeks back, or in fact days back, Apple started their own flavor of AI called Apple Intelligence. If you have not read about it, just check the video. I'll put a link above somewhere at this timestamp. So basically, there's a lot of chatter in this space, and the intent is to be able to talk about some of them. So LLMs have, human beings have always expected AI to have some sort of autonomy, like autonomous behavior, which is essentially the artificial intelligence or artificial part of it. Now, this is significantly far from what is termed as something as a generative AI or Gen AI, but it could be much better to think about it in the form of something that assists you, interacts with your surroundings, can gain a perception of it, take decisions, take actions in response, and perform suggestions. So LLMs agents, as this paper describes, have been rapidly developing. They are having a lot of different interactions and they are doing a lot of bunch of decision making. So when we look at this landscape, right, what do we have? We have a single agent where an agent really implies that you're doing something and it's executing a series of steps. Now it is executing them by providing a reasoning to the steps. It's not a blanket workflow that executes step 1 through n and achieve an output. That's not the intent. I think it can decide what are the steps that are needed basis the kind of question or task given, and can decide or leverage tools such as, okay, this question requires a Google search or this question requires an API call and a bunch of other stuff. Right. So that's specializing agents. That's a single agent conversation. What can be a multiple agent scenario? You can have agents which are having distinct capability, like within your whole system, you have an agent which is responsible for a certain capability. Like let's say you're trying to do summarization. There's an agent which is responsible for taking data and decomposing it into structured or unstructured and joining and all of that. Then there can be another agent which can have a domain understanding, which could be, you know, hooked up with a domain specific LLM like finance LLM, and kind of give you that insight from a finance perspective. And then there can be another agent which is finally trying to summarize and collate all of this information and present it in a format that is expected. So that's multi-agent scenario. So two things are really important when we think of multiple agents and the capabilities become advanced. Specializing LLMs into various distinct agent, each will different capabilities would give you a broader spectrum. And the interaction between them, and we'll talk a little more about interaction, will give you a good picture into what how things can evolve. And evolution is a very interesting concept. Now this will go somewhere towards reinforcement learning, RLHF, like reinforcement learning based on human feedback and stuff like that. But this paper or this idea goes a little deeper in that space, so that agents can learn from their interactions and behavior to uh, optimize decision making. All right, let's move forward. So here's a bunch of LLM based multi agents. As I said, the scenario and landscape. Okay, I'll try to move a little bit aside. Okay, so you should be able to, okay, this side, you should be able to see the whole of this thing, which is different areas of LLM. So there's frameworks, there's problem solving agents, there's world simulation agents, there's agents having different abilities to do acquisition, and then you have data sets and benchmarks. Now data sets and benchmarks are significantly important. I am not going to be talking about that in this video because evaluation, data sets are whole deeper conversations to dive into. But then this should give you a picture as to how much of a riding trend there is. All right. Now, what I want to do is how are LLM agents aligned with the collaborative task solving environment. So there's a bunch of things to understand when we talk of agent and environment interface. The first is the interface itself. The second is the agent characterization or the profile of the agent, which is what I was trying to explain before that, how an agent is characterized to behave in a certain scenario. And then then the third point could be the communication. And finally, the capability of acquisitions, which is how the agents has inherently develop better ability. So it might sound a little, science fiction, but it's not. This is very real. I know this is a little bit of theory as well, but if you double click on any of them, there's tools, libraries, frameworks, and we'll get into building agents pretty soon. So there's a bunch of background provided in this paper. I'm not gonna get into those specifics, but just to highlight, there's a decision-making thought for a single agent-powered LLMs. Then there's a tool which you're specifically talking, and then there's the memory. So the memory is kind of the space where it learns or understands. And then when we think of single agent versus multiple agents, all of this just zooms and expands. So yeah, we'll go and talk about each of them. There's an architecture diagram which we'll talk about. So what does an agent environment interface mean in this case? Uh, that's basically where we are talking of that agent. So if you are, what kind of task you are performing, what kind of activities you're having. So if you have some sort of a software development, so the environment will be software development. If you have a financial market, the whole environment could be completely different and stuff like that. So this talks about what kind of environment we have and what sort of interfaces we have around them. Profiling refers to the ability for agents that, what roles they are taking. So when you have a software development agent, it could have a product manager, it could have a scrum master, it could have a developer, tester. So essentially the persona or the profile of that agent, and there can be multiple methods to arrive at the profile. Last is the communication, and I want to, I think, stop at communication and one point after that. So the communication between agents can be really, really complex, what sort of communication structure you are doing. And if you kind of zoom in into this diagram, there's a bunch of different formats and diagrams to think about. So there's the layered architecture, which is very standard to have you. There's a query coming, it goes to multiple agents and then to another set of agents. So there's a layering of sorts. There's a centralized picture, which is this diagram where there's a top agent or a head agent or a and orchestrator agent, and that kind of does all the orchestration around it, which is centralized pattern. And then there's a decentralized. So there's a bunch of agent each talking among themselves, and then there's a finally a shared message pool. So this is more of a communication hierarchy, and it has to be very well thought of before building systems using it. Here's some kind of a general architecture about agents, and I'll probably spend another minute here. So what you have at the bottom is the environment. The environment can be, a software environment or a physical environment. Software environment could be sandboxes, code environments, games, etc. And then there's augmentation by human. Docker is just helping virtualize things, I'm guessing. So with the environment, the agents would either take action and get feedback. That's the only thing that it can happen. On the right hand side, you have all the LLM based conversation. There's a profile, there's goal, communication model, beliefs, RAG architecture, which is documents and retrieval, prompts, and inherently going to an LLM, ChatGPT in this case. And then you have a completely deeper multi-agent system where you have a orchestration, you have a profiling and bunch of stuff. So you'll have to think of this very deeply, very similar to like you do your API design or a system architecture to be able to, uh, leverage the technology well. So we have touched upon communication, and again, communication structures have to be thought much more deeply. This video might not be able to get into it. Finally, the last topic which I wanted to take was how can agent acquire new capabilities, which is essentially, how can they get feedback? So feedback can be coming from multiple different places. The first could be the feedback from the environment itself, which is, whatever it is interacting, it's receiving feedback. Now, agents have to be made aware that they have to be collecting feedback, otherwise they will not. So again, things have to be coded out. Then how do they evolve basis the interactions that they have between themselves? Finally, what sort of inputs they get, which is like a human feedback, and there could be also scenarios where there is none. uh, yeah, I'll just leave a teaser by talking about applications as well. So where can this come into? Bunch of this could be a problem solving. So very smart workflows, think of inherently workflows that can be done by people, or at least beginner friendly workflows can be very easily done by agents. I'm not saying they cannot handle complexity at all. That's not the point. So the table gets into a bunch of different kind of use cases and what's the work that has been done in this space, what sort of agent interfaces, profiling methods, the different profiles that have been done, agent communication, agent capabilities, acquisition, tons of it. So there's a bunch of stuff happening. So you can have an agent which is a gamer, so you could have it playing PUBG, and that agent is designed to maximize number of kills and whatnot. So there's a lot of different capabilities that you can do when you think of agents, and essentially how they can help you solve problems and how do they evolve. So it's a very, very interesting space which is evolving. And there's a lot of organizations being bullish on this technology trend of leveraging agents to solve their problems, to solve their workflows, to optimize things within their whole surroundings. So you could have a agent that can do the analysis every start of every day and end of every day, uh, like a market analysis. If you're a trader, if you're a software developer, it can, keep scanning your code base commits over a period of time and give you some suggestions, recommendations based on your coding style. So hyper personalization can be another trend out there. So bunch of things popping out in this space. Very, very interesting, very, very exciting. Stay tuned for more conversations like this. If you have not subscribed to my channel, please do. I talk about technology, software architecture, AI, system design. I know it's a mouthful and a bunch of things, but essentially sharing what I've learned in my journey as a, you know, person who's been building systems software for his career. All right, stay tuned for next videos. Bye bye.